Hey everyone, welcome back. In this lesson we're going to continue working with logarithms just the same way we have been in the past couple of lessons. So in this one we'll make use of a couple of the logarithm rules that we examined last time out. And yeah, we'll just do a few practice problems and then that'll kind of be it. I'm going to squeeze that in there. Yeah, we're just going to do a few practice problems in this one, and then in your next lesson we'll have something of a test review, and then that'll be it for this unit. So the first few questions that we're going to go over aren't necessarily going to involve the logarithm rules, but I'll just put them up here in case you wanted to remind yourself of them. So we've got something like, I'm going to make that a capital A. So if we've got something like this, m, n right beside each other without any symbol in between means that they're being multiplied together. So log base a of m times n is the same as log base a of m plus log base a of n. All right, that's the first rule. The second one that we're going to use is log base a of m over n. Let me make that parenthesis a little bit bigger. M over n, or m divided by n, is the same as log base a of m minus log base a of n. And then the third one that we're going to make use of is log base a of m to the exponent, let's call it p. Log base a of m to the exponent p is the same thing as p times log base a of m. Alright, so those are the three main things that we're going to use in these practice problems. So we might not actually end up using all of them, but I'm just going to work through a few problems. A couple of them are going to be more basic, and sort of the type that you might expect to see on the test. Some of them aren't necessarily that hard, but the amount of time it would take for you to calculate the answer might be a bit too long for the test, so some of them might be a bit much for the test, but you'll still see how they work in practice. Yeah, that's about it. So we'll just go through a few practice problems. This one might be a bit shorter than some of the others, but we'll see how many problems we get through before I jump ahead of myself and say that we'll be done early. So let's start off with the following. So the first one we're going to do, we may have done this one already, but just as a refresher, if we didn't do this one already, we've done something very similar to it. So the first one is log base 5 of 625. That's the first one that we're going to try and calculate today. So, so there are a couple of ways that you can think about this. If you know what the square root of 625 is, that could help you sort of work backwards to get the answer in a problem like this. But assuming that the number here doesn't immediately jump out to you as a perfect square, we'll just go ahead and calculate it the way we've been calculating it so far. So we know we're going to be dealing with this base 5, and we're going to be multiplying some number of 5s together to try and get an answer of 625. So we'll start off with 5 times 5, which is equal to 25 by itself. So this right here is equal to 25, but that's not nearly big enough for our answer, so we'll throw in another 5 there. So 5 times 5 times 5, that whole thing is going to equal 125. So that's still not big enough, so we'll throw in another 5 there, and then we'll just quickly calculate it to see what this gives us. 125 times 5. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. 5 times 1 is 5, plus 1 is 6. So that gives us the 625 exactly that we needed for our answer. So once we've hit that target number and all the test questions that you get, the target number here will be something that you can get by just multiplying a few of these together. But dealing with logarithms, that's not a rule. This could have been any number, and we would still have to try and figure out the answer. So like 624 would have been a perfectly valid number to put in there, and then our answer just wouldn't be a whole number. It would be a decimal answer. But we're not going to worry about that because that's not the type of question that I'm going to put on the test. This is sort of just an intro to logarithms, what they are and how they work. So assuming that your target answer is exactly some power of this base, then that means you just need to multiply a few of those bases together to get to your final answer. So in this case we multiplied 1, 2, 3, 4. We multiplied 4 of these 5s together to get our answer of 625. So our answer to the question is 4, because that's how many 5s we had to multiply together. Okay, so hopefully that's making sense. So that's the first and one of the simplest examples that you might see for the remainder of this lesson at least. The next one that we'll do, it's slightly more complicated, but only because of the base that we're dealing with. So we'll do log base 7 of 343 this time. So with this one, it's set up exactly the same way. It's the same level of difficulty. We're not dealing with any of the log rules or anything like that. So what I'm going to do is I'm just going to start off by multiplying a couple of 7s together, because that's the base that we've got over here, and we'll see what that gives us. Now, multiplying 2 7s together, that'll give us 49, which isn't nearly big enough, so we'll throw in another 7 and see if that gives us our answer. Now, I'm not expecting you to know 49 times 7 off the top of your head, so feel free to calculate it off to the side. 9 times 7 is 63, carry the 6. 7 times 4 is 28, plus 6 is 34. So that's given us our answer exactly. Our target answer of 343 came from multiplying 1, 2, 3 of these 7s together. So our answer to the actual question will be 3. Alright, so those two problems, relatively straightforward, nothing overly confusing right there. So we'll jump on to our third problem then. We're only going to do, I think I had, what, 6 lined up for today? Yeah, so those are 2 of the more basic ones. Those would be the type that you might expect to see on the test, and then possibly one of the remaining ones, but probably nothing too bad. So this is the type of problem that you should be able to do for the test. It's not overly complicated, and we won't, you don't need any of the logarithm rules or anything like that to get an answer to these ones. So we won't have to worry about things like that on the test if you're given a question like this. But for the next one, you would need to worry about those logarithm rules, because this next one is written out as log base 3 of 81 squared is equal to something. Now, if you wanted to, what you could do is you could figure out 81 times 81, because that would give you 81 squared, and then figure out whatever that answer comes out to is equal to 3 times 3 times 3 times 3. How many times do we need to multiply 3's together to get to that answer? That would sort of be the long way of going about it, but we're going to go about it the shorter way, which is using one of the logarithm rules. So the way that one will work, so we're going to use the rule that involved shifting around the placement of the exponent. So we had log base a of some number m to the exponent p is equal to p times the logarithm base a of m. So all we really have to do here is we've got a whole bunch of letters down here, and we've got a few numbers up here. So all we have to do is mix and match and figure out what numbers up here correspond to which letters down here. So let's start off with the base. We know we've got base a down here, and we've got a base of 3 up in our actual question. So we know a is 3 in this case. So if I look over here, I've got log base a in my answer. So I know for sure I'm going to have log base 3 of something as part of my answer. Now let's look at this. We've got m down here, and we've got m over there down there as well. And up here, that would correspond to the base of our power, of the thing that's in our argument here. So that means that this m down here, where we're using only letters, corresponds with this 81 up here. So that tells us that m is 81. So we've got m here, which is 81 there. We've got m over there, so that means we'll throw an 81 in there. So now we're almost done. The only thing left is p. So here, when we're using all letters, p is our exponent, and on the right hand side, we've ended up basically taking the exponent from being up here, an exponent on m, and just chucking it out into the front of the expression, and that's where it sits in our answer. So if we can figure out what p is, we can plug that into our answer. So up here, the exponent in our argument, which is 2, corresponds with where p goes down here. So we know that 2 corresponds with p. So if down here we took this p and we just moved it out front, just chucked it out in front and left it there, we're going to do the same thing with this 2. We're going to take it out front and just leave it there. So we put a 2 out here, we're going to leave it there, and notice that there's no more 2 in the exponent. We're not squaring that 81 anymore. So now we're not quite finished because that's not a final answer, but it is easier to get to the final answer because we're dealing with a smaller number in our logarithm now. Over here we were dealing with 81 squared, which is some gigantic number. Over here we're not dealing with anything bigger than 81 itself, which, while it's still a bit of a big number, it's not quite as big as 81 squared by any means. So what we've got now is 2 times, the fact that we've got 2 right next to all of this without an operation in the middle, once again, means multiplication. So it's going to be 2 times the logarithm base 3 of 81. So let's figure out that logarithm base 3 of 81 first. Let's figure out this part first. So if we wanted to know log base 3 of 81, let's multiply some 3's together and see what answer that gives us. So we've got 3 times 3, that'll give us 9. Multiply by 3 again will give us 27. Multiply by 3 again will give us 81. So 3 times 3 times 3 times 3 is equal to 81. So that means we have to multiply 4 3's together in order to meet that target number. So our answer to this logarithm will be 4, because that's how many 3's we had to multiply together to get that answer. Alright, so what we can do from there is now we've got an answer to what this logarithm part actually is. This whole thing right here is equal to just 4. So now we know that it's going to be 2 times, this whole thing has been reduced down to just a 4. So that means we're going to get our final answer, if I move this down, it will be equal to 2 times the answer to that logarithm, which is 4. And 2 times 4 is equal to 8. So that would be our final answer for this question. Now the way you could check your answer to a question like this would be to, if you just go back and see what the question was asking, this is the exponent that you would have to stick on a 3 to get the same answer as 81 squared. So that's a lot of numbers that I said there, so let me get rid of this. Basically what we're asking is, if our base is 3, what exponent do we need to stick on that 3 in order to get an answer of 81 squared? And we've got an answer of 8 over here, so that's telling me that it's going to be 3 to the exponent 8 is equal to 81 squared. And the way that you can calculate whether that's right is throw into a calculator 3 to the exponent 8 and throw into a calculator 81 squared, or 81 times 81, and see if it gives you the same answer. The other way that you could go about this is if you consider exponent rules and dealing with the rules for like adding and subtracting and multiplying exponents together. 81 is the same as 9 squared, right? So what we basically have here is, if I get rid of the actual question now, because we're just exploring different ways to check our answer now, if we look at this 81 differently, 81 is the same as 9 squared, right? So I could write that as 9 squared squared, right? 9 squared is 81, and then that 81 needs to be squared. So that's telling me that 3 to the exponent 8 is equal to 9 squared all squared, right? But that's still not helpful. That's not really any more helpful than what we started with over here. But we know from our exponent laws that if you've got a power, so you've got a base and an exponent, and that whole thing is raised to another exponent, you can simplify that down to just being one base, which is the base that you started with, so 9, and then you take those two exponents and you multiply them together. So we've got 2 times 2 would be 9 to the exponent 4. But still, that's not useful. We've got a base of 3 here, we've got a base of 9 there, so that's not really helpful. But we know that 9 is the same as 3 squared to the exponent 4. Right, so 9 is the same as 3 squared, but because we had 9 to the exponent 4 over here, we have to take this 3 squared and raise it to the exponent 4 over there. And so we can sort of do the same process that we were doing down here, is you've got one power here, you've got a base and an exponent, and that whole thing is raised to another exponent. So we're going to keep the base the same, and we're going to take those two exponents and multiply them together. So we've got 2 times 4, which will give us 8, which, if you look at what we had over here, is the same thing. So that's another way to check that you've got the right answer. So if you don't have a calculator on you, you can always just fiddle around with the numbers and see if you can make sense of your answer. Alright, so that's just another way to go about checking your answer. That's not something that you would necessarily have to be able to do, but if you're not sure if your answer is right, being able to check it is useful to be able to do. So let's move on to another one. This one is also reasonably easy, and then we'll get into a couple more slightly more complicated ones, and then call it a day there. So this next one is going to be log of 1 million. So how do we solve this? Well, we know that if there's a logarithm of some argument, we'll call it m, that's the same thing as log base 10 of that argument m. So basically, if there's no number written in, we're assuming that there's a little invisible 10 sitting down there. Alright, so it's log base 10 of a million. Now there are two ways to go about getting the answer when your base is 10 and your number is something like this. And the way you could do that is, well, just exploring multiplication patterns for 10. Right? If I had 10 squared, that would equal 10 times 10, which is equal to 100. Right? If I had 10 cubed, that's going to equal 10 times 10 times 10, which is 1,000. So if you go ahead and look at the pattern, you write out a few of these, you'll notice that the exponent here, 10 to the exponent whatever, is the same as the number of zeros in the final answer. 10 squared, so an exponent of 2, the answer is 100, which has 2 zeros in it. 10 cubed, that's an exponent of 3, your final answer is 1,000, which has 3 zeros in it. So you could just solve this by counting how many zeros you have, and that would simply be your answer. 10 to that exponent would give you this number. So we want to know how many zeros are here. That'll tell us what our exponent on the 10 needs to be so that we get an answer of a million. So we're asking 10 to what power, 10 to what exponent is going to give us an answer of a million. Well, if we look at the pattern from before, if we have 3 zeros in our answer, our exponent is going to be 3. If we have 2 zeros in our answer, our exponent is going to be 2. For a million, we have 6 zeros in our answer, so our exponent must be 6. And therefore, 10 to the exponent 6 would give us a million, so the answer to this logarithm would be 6. The slightly more complicated way of going about it, it's not really that much harder, but if you don't remember the patterns for powers of 10, you can always just sit there and try and crank it out, right? 10 times 10 is going to equal 100, times 10 is equal to 1,000, times 10 is equal to 10,000, times 10 is equal to 100,000, times 10 is equal to a million. And then you can count all the 10s you have, so you've got 1, 2, 3, 4, 5, 6, which matches the 6 that we got up there. Alright, so hopefully that makes sense. That's another example that you could expect to see on the test, just because there isn't that much actual calculation involved, because dealing with 10 isn't that bad, especially when your target number is something as nice as a 1 followed by a string of zeros. Yeah, it's just to remind you what it means if you've got a logarithm with no base written underneath. And it's the type of question that I could put on a test just to try and scare you, because it looks a little bit scary that you've got a 7-digit number as your answer, but if you remember the multiplication rules for 10, then it's really not that bad. So the next one is going to be slightly more complicated, and we're going to make use of one of the logarithm rules for this one. So this one is going to be log base 2 of 4,096. I would say don't expect to see a question like this on the test. So that's a 4,096 right there. Yeah, don't expect to see this on the test because this will take some time to calculate, but I'll show you the shortcut for figuring it out. Minus log 2 of 1,024. So, looking at this, you could initially think to yourself, well, okay, I could figure out what this logarithm is by just doing 2 times 2 times 2 times 2 times 2 a whole bunch of times until I got to 4,096. And then I could do the same thing over here, and then I would just take my answer from this one, my answer from that one, subtract them because we have a minus sign in the middle, and I would get my answer. And that would work, but you could rewrite this using our logarithm rule for division. Remember that log base a of m minus log base a of n is the same thing as log base a of m over n. So we'll take the first one, so this 4,096, and that'll become our numerator over here. So we've got a 4,096 in there. And then our denominator will be the second one. So this 1,024 will become our denominator. So we've got 1,024 down there. So now we've reduced this down to one logarithm. And if we can simplify that fraction, that'll be fantastic. But now we only need to solve this one over here. And we don't have to worry about these two at all. So looking at the number 4,096 and the number 1,024, the relationship between those two might not actually jump out at you very readily, but it turns out if you take 1,024 and you multiply it by 4, 4 times 4 is 16, carry the 1, 4 times 2 is 8, plus 1 is 9, 4 times 0 is 0, 4 times 1 is 4. So this tells us that 1,024 times 4 is equal to 4,096. So that also tells us, sort of by extension, that 4,096 divided by 1,024 is equal to 4. So this is the crucial piece of information that we need to solve the problem from here, because now we can reduce that fraction. That's 4,096 divided by 1,024, which comes out to exactly 4. And this is a much, much easier logarithm to solve than either of these. And this is just asking us 2 raised to what exponent will give us an answer of 4? And, well, we already know that 2 squared is equal to 4, so that tells us that our exponent on 2, in order to get 4, must be a 2. And so that would be your final answer there. If you wanted to solve it the other way, you could. For log base 2 of 4096, it turns out that if you multiply 2 by itself 12 times, you would get to 4096. So your answer to this first logarithm over here would be 12. And for this one right here, 2 multiplied by itself 10 times would give you 1024. So our answer to that logarithm would be 10, and then you could just do 12 minus 10, which would also give you 2 as a final answer. So both of them are perfectly valid, but I would prefer to do it this way, because then when I'm actually figuring out the logarithm part of it, it's much, much simpler, whereas over here you're going to be at this a while if you're trying to figure out how many 2's you can multiply together to get 4096. Alright, so that's it for that one. We'll do one more, and this one is something that I could put on the test, not the one we just did with the 4096, but this last one that we're about to do is something I could put on the test just to try and throw you off a little bit. So here's the last one. So this one is going to be log base 3 of 81 minus log base 4 of 16 minus log base 5 of 25. Now the reason this type of a question could trip you up on the test is that if you've spent a whole bunch of time focusing on studying your logarithm rules, you might feel tempted to try and use one of them. But the thing that you have to be careful about with the logarithm rules is these two bases need to be the same, and these two bases need to be the same in order for me to use the log rules. They don't all have to be the same. If this one and this one were the same, but that last one was different, then I can apply log rules for division or whatever I want to this one here, and then I can deal with that separately. But you might feel tempted to try and do it because you've got one logarithm minus another one, and most of the times when we've seen that, it's led to us using one of the logarithm rules. But you have to have the same base, the same little guy down here in your subscript, and since none of them are the same, we actually can't use those log rules at all. So for this one, we actually have to just grind it out and figure out the answer by calculating each one individually. So if we go ahead and calculate this first one, how many 3's do we have to multiply together to get 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So that tells us that we're multiplying 4 3's together to get to 81, so the answer to our first logarithm is 4. Now we're subtracting for the second one, so it's going to be 4 minus whatever the answer to this is. And for that, it's just how many 4's do we need to multiply to get to 16. Now that's fairly straightforward. 4 times 4 is equal to 16, so it didn't take much work to get to our answer there. We've only multiplied 2 4's together, so that means our answer to this logarithm is going to be 2. So I'm going to take that 2 and I'm going to throw it over here. And then lastly, we've got log base 5 of 25, which is asking us how many 5's do we need to multiply together to get to an answer of 25. And so if we do that, we just need to multiply 2 5's together, which gives us our answer of 25, because that's 5 squared, or 5 times 5. We already know that, so that means the answer to this logarithm is 2 as well. So once again, I'm just going to take that and I'm going to throw it over here. So we've got 4 minus 2 minus 2, which of course, if we go ahead and solve that, 4 minus 2 is 2, and then that 2 minus 2 is going to leave us with 0. So that would be your final answer for this one. Would be 0 in this case. So you don't have the option to use the log rules if the bases are different. There are ways to get around having these different bases, but that's not really something that we've talked about so far in this unit, so don't really worry about it. If you guys want to see something on it, let me know and I'll throw something together on that. But it's not anything that you're going to need to worry about on your test or anything like that. So, yeah, so the next lesson that you'll see, I believe, unless I've miscounted, but I don't think I have, the next lesson that you'll get after this will be a test review for logarithms, and then your logarithm test will be coming up not long after that. And then after that we'll be done our unit on, well, it won't be just logarithms, so your test will be on exponents and like, you know, squares and square roots and things like that, and a little bit of logarithms. So we've talked about 3 sort of different topics, but they're all intertwined and related to one another, so your test will cover all 3 of those, and then we'll start a new unit soon after that. But yeah, your next lesson will be just a test review, and then you guys will have the rest of that period to study if you happen to get through that review before the end of class. As always, reach out to me if you have any questions. Otherwise, I will see you in the next video. Have a good one.